Something a little bit different for you guys today. I am actually with Professor Johannes Braumann, who is the creator and lead developer of KUKA prc, co-founder of the Association for Robots in Architecture, and the founder of Creative Robotics, a research group at the Art and Design University of Linz, where I work alongside him as lead researcher. G'day, Johannes.
Hey, Carl. Thank you for the invitation.
You're more than welcome. How are you?
Very good. We're in lockdown, as you know, so it's nice to chat a little bit, use the time.
Absolutely. I'm looking forward to it. You and I share pretty similar backgrounds, having studied architecture and sort of ended up working within robotics. So I think my first question today is a pretty simple one. Why robots?
Why not robots? No, why robots? At a very basic level, because other machines were more expensive. So for me, that came from a research project at TU Vienna that was headed by my colleague Sigrid Brell. And the idea was five-axis model building, CNC model building. So not really parametric fabrication or anything, just model building. And they had a budget for 100,000 euros. And for that money, just wasn't possible to get a proper five-axis milling machine at that time. And so then my colleague kind of took the chance to go for a KUKA robot because KUKA had published the KUKA CamRob software. So this was kind of the first software by a robot manufacturer that was able to post-process G-code to run on the robot. So that you had this kind of CAD-CAM interface. So similar stuff had been done by companies for quite a while, but it was new to have this really as an integrated robot function. So that was a nice chance just to say, well, let's try something new at that time. And this is how we ended up with a KUKA. So it was set up. We were very impressed how big and orange it is. For today it was a KR60, so it doesn't feel that big anymore. But at that time it was a pretty big machine. And and then we started to get a bit limited by it, and this then led to other things. But I kind of, got into that. I've always been interested in robots, so for me it was just a very good opportunity to be invited to join that research team.
Oh, that's excellent. Could you give me a brief history on KUKA prc as well as the association?
Yeah, for KUKA prc, that really is the result of our research into using robots for non-standard purposes. So, as I mentioned, we got that for at TU Vienna, and the idea was also to use it for teaching. So we had classes with architects, and then we kind of had to teach them how to use first Rhino. Not everyone knew how to use Rhino. We had to teach them how to work with CAM software to turn their 3D models into toolpaths. And then we had to teach them how to use KUKA Sim Pro, the simulation software that then turns the 5-axis G code into 6-axis robot code and also the robot simulation. And this was quite a pain. The software was complicated, it was expensive. We had less licenses than we had students. So basically, this was this round robin. So a new person logs in, the other person loses the license, and then it kept on repeating. So for us, it was kind of the logical step to really first say, well, why do we even have to use CAM software? So the first step was just to do 5-axis G code out of Grasshopper. And then the next question was, well, if we can do a 5-axis G code, why can't we do 6-axis code? So we don't need this kind of pipeline in KUKA Sim Pro anymore. And then the next step was, well, if we're already generating code, why can't we also simulate the kinematics? So this was then the next step, kind of to keep on adding features that we needed. So I think this is a bit the different approach than for commercial software. So if you think of commercial software, you have your very specific client and you're developing software for that purpose. And in our case, we were both developer and client in the same person because these were the features we needed to do the work that we were interested in. And it was a very lucky coincidence that at that time Grasshopper was getting so increasingly popular. So I don't think it would have been possible in another software for us to learn as much, but then also to make it available as much. And I mean, this then kind of led into the association as well. So in a very early stage, we did a workshop at a conference in Vienna. So that was just locally. But we were very interested to see how many people were actually interested in robotic fabrication. So we had people from Snowhatter, we had people from ETH, from Innsbruck, from Sharjah University, so people all around the world coming to see how to work with robots. And we really weren't aware of that. And this was kind of a stepping stone. But then we felt it's important that this is kind of an initiative that's not driven by a single university, but this is something that should kind of transcend it a little bit, to act as a platform for people to come together to exchange ideas, knowledge. And something like that didn't really exist at that time. So you had maybe fabrication sessions in other conferences like Acadia. So Acadia was always heavy on fabrication, but there weren't no robotic sessions. And all the kind of robotic knowledge was kind of arcane. So you had the very high end with ETH Zurich, who employed mathematicians and programmers to get that to work. And it didn't feel like something that people or we could do by ourselves. But then the more we worked with it, we thought, well, this is kind of not, there is no magic in it. So this is a relatively stupid machine. You just need to tell it what to do and how to do it.
I think you've sort of touched on my next question a little bit as well, which is fantastic. What was it about the Grasshopper environment that was the inspiration to include robotic control as opposed to something standalone or another software package?
Yeah, the problem is always standalone software is kind of tricky because you are kind of responsible for everything, and we might be good at working with robots, but having a standalone software needs so much more than that. So I think it's very ambitious to say you want to make that one robot programming environment that covers all the needs. And I think this is really the super nice part about Grasshopper. And I think also a big reason for the success of Rhino in general, and building up this kind of ecosystem that then comes together in one platform using a very accessible software developing kit or API. So I think that was really the core, that you don't need to worry about everything. So a big part of the user experience in Grasshopper is already defined in a very nice way by David Rutten. So then you really only have to figure out how can you use these kind of concepts in an efficient way for robotic fabrication.
That's a good answer. So when you consider the more traditional way of programming a robot, whether that's online or offline using KRL or Rapid, or depending which robot you have, what do you think it is about KUKA prc that feels fun and intuitive method for programming a robot?
I think the difference is really that it kind of abstracts this kind of idea of movement to geometry. So I think this is really the main part. So for me, this is kind of this levels of abstraction. And for me, having a robot is an abstraction of having a machine. You don't need to build it from scratch. You don't need to deal with all the tiny aspects of mechanical engineering, this big amount of know-how that's required to build a reliable and well-working, accurate machine. So you just need to worry about how do I need to move it. And then I think the KUKA prc provides that additional level of abstraction that you don't necessarily need to think about how you need to move it, but you can constrain that movement to a geometry. And of course, then the interesting part is if that geometry is not static, but if that is parametric. So that you have something that can be individualized, that can be changed. And then whenever you do some change, you see how it affects the robot. And this is a very kind of intuitive learning process, I think. So I like to compare it to taking like a photo with a digital camera. I mean, probably now people can't imagine doing it with an analog camera, maybe. But I mean, at that time you did something and then you had to wait for a week until you got the photos. And a week later, it's very hard to learn from your mistakes. So you can't really figure out that quickly what went wrong, what went right, how do I improve. And I think in Grasshopper, the nice way is that you can interact with this parametric model in a super intuitive, efficient way. You do something, you see what happens to the robot. And I think it allows you to learn much quicker about these kind of constraints that the robots have in regards to reachability and all these things than if you were to do this in a more traditional way.
I've obviously been using KUKA prc for quite some years now, and have started doing workshops and doing my YouTube videos and introducing people to KUKA prc.
Our premier user.
Thank you very much. Do you think it changes how people perceive the potential of the robots?
Well, I think it's really the main step is really making them not afraid of machines. So I think whenever you hear robots, robot is a very loaded term. It can be applied to many different machines. But even if you just think about industrial robots, they just seem so complicated. And when you talk about programming, it sounds like something where, like in the movies when you hack your code and then you have, I don't know, green text on black background scrolling down or whatever. And I think this is really the kind of thing when you see this more playful approach of just, changing a few curves around, putting in some components, seeing the robot move around. I think it kind of helps you to see that this is not something that is so special. And I think this is super important because for me, kind of robots, or especially industrial robots, are really tools for people with specific skill sets. So if you know how to do something with your hands, if you are a carpenter, if you are a craftsperson, if you developed a super interesting 3D printing process or whatever, I think this is really the biggest potential here, to allow these people to put their own knowledge to the robot. Because you might have a brilliant programmer, but that programmer might not know anything about the process that he or she is defining. And I think this is a very critical part, to open it up to the people who actually have that process knowledge.
Through my experience, like back at the University of Tasmania, where I was introduced to KUKA and KUKA prc, it was a case that they had the robot because robots in architecture has become so popular over the last decade, and it's quite fashionable to be involved and have a robot in your school or even in your office, architectural office. But a lot of these systems and cells go largely unused. And I've seen this at quite a few universities over the last couple of years. What would you propose needs to change in order for more exciting output from these facilities and the potential that's within them?
Yeah, I think a big challenge here is really the structure of universities. So that there is so little kind of permanent employment, because you have a researcher, that researcher is here for 3 years, 5 years, whatever, for his or her PhD, and then that person usually leaves again and then takes the entire knowledge with that person. So I think this is, on the one hand, something that's not really specific to robots, but something that applies to many, many different fields and university, that brain drain is just a real kind of challenge. And on the other side, of course, it used to be that process was just, and the knowledge was just very self-acquired in a way. So if you think about robots, there isn't that much documentation to go around. So all those genius robot integrators who know everything, basically there's a reason why these guys are in their 40s and 50s, because they just kind of experienced all the different problems that you can encounter. They found solutions and they learned from it. And I think this is really just is very important, that ideally we find ways that this knowledge is more easily accessible, that this is not just through trial and error, but really through that there are knowledge platforms. I think a very good platform is the Robot Forum. So if you Google for anything relating to KUKA robot question, it pops up at the very top of your Google results with good reason. But at the same time, this is not really curated in a way, because you still, sometimes you have questions and answers, but you don't know, did that really solve that? People don't kind of reply if that is now the solution or if this still didn't work. So I think this is really something that also in Linz we're trying to solve, to make this knowledge more easily accessible to a wider group of people.
I'm obviously a big fan of KUKA prc, if not the biggest fan.
Thank you very much.
You're welcome. But what do you think is the biggest shortcoming or failure of the software package?
Ooh. What I see as a big challenge, and now kind of deflecting a bit to Grasshopper in general, is that Grasshopper is an acyclic directed graph. So basically, it's a system that goes in one direction and can't loop. I mean, you can say that there are some ways to get Grasshopper to loop data, but at its basic kind of level, this is what it is. So for now, we're seeing more and more, we as a research group also, but also as developers, see more and more projects that want to incorporate real-time feedback and interaction. So having this kind of, if this happens, then do that. If the other thing happens, then do that. And I think a really big challenge is how to show this kind of decision process in Grasshopper as an environment. So I feel like we developed it for having this more initially like offline process of saying you have some parametric data, and then at some point you have your robot control data file, you send it to the robot, you run it. That works perfectly, but I think incorporating feedback is really a challenge where we're still struggling to find a perfect solution. So we use MX Automation, which is a very nice solution and works quite stably now, I think. But you have those different ways of how to deal with new data. So if there's new data coming in the Grasshopper graph, what happens to the robot? Does it like queue it up? So it first makes the first batch of data, then when it updates, it makes the next one. Does it stop the current process, go back and start new? Does it adapt the toolpath? So we can do all these things in Grasshopper, but it doesn't feel native in a way. So I think this is something we're really actively looking into, and it might be that Grasshopper just isn't the perfect platform for that. So on the bright side, we've now been working quite hard on making KUKA prc quite platform independent. So a couple years ago, we had the integration for Autodesk Dynamo, which to be honest, didn't see that many users for some reason, but it was for us a very good step towards trying to make it more universal. So now we have implementations running on Unity, running in the cloud, running in the browser. So I think this is also partly where this is heading, that we need to be on more platforms and to make that more accessible as well. Of course, the challenge being that if you work in Unity, if you work in the browser, it's not as neat as Grasshopper anymore. So then you're targeting developers and not users anymore. So there are challenges left, many of them.
From my perspective, since joining the team at Creative Robotics, I've sort of witnessed that KUKA prc, what I imagined as a single plugin for Grasshopper, has sort of started to grow into a platform all of its own, where it's branching out to, like you said, Unity and online and cloud access. Is that more of the direction where you see it developing into a full platform?
I think this will be interesting, but I think we also need to figure out, as the Association for Robots and Architecture in that case, how we want to approach that. So for us, for example, open source or not open source has for a very long time been a kind of loaded question. So how do we approach this matter of intellectual property on one side, but on the other side being like an open platform? So we still haven't found a right answer for that. So we're trying to go this kind of middle ground by making most of the features people need available freely anyway. But then when we open it to developers, this of course opens up many new questions. So for example, about liability. So if something happens and then someone proves that the simulation was off, how do you deal with this kind of deep access that people have by themselves? So it's for us something we haven't really, I think, figured out a solution yet. But we would like to make it, I think, accessible more and more to developers as well, that we see more custom solutions. So we have a few partners that are working on stuff, that have published things, but we cannot share this kind of commercial projects. But there is kind of progress in in that area, I think.
I think that touches really well with some of the work we're doing at Creative Robotics, where we work with industry partners as well as more creative endeavors. And I'm very curious in your answer with this one, as we do so many projects, and it's very hard to give a global classification other than they all incorporate a robot or even several. Can you sum up creative robotics in a single sentence for me? So I can answer when people ask me, what do I do?
Yeah, the what do I do question, that was for me something that got much easier once I was at university, like or back at university as robots in architecture. Like after university, when we did our own research projects, that was kind of challenging to tell people what do you do, because we were not a company. If you say you're an association, that sounds like you're I don't know, saving animals from the street or whatever. So for us, that was being now at university saying you're a researcher, people just accept that you kind of do strange stuff, you talk about robots. So this is then kind of clear. But to go to the back to the main part about the question, what creative robotics in one sentence? I think it basically means that we kind of explore robots as an interface that allow us to affect our physical environment through digital data. It's not a complete definition, because I think now more and more data is kind of flowing both ways and whatever. But I think this is kind of the thing, that robots are not fabrication machines, but they're interfaces. And they're interfaces that allow us to connect with the world that we interact with and through code. And I think this kind of sums it up as a very kind of general sentence. You wanted one sentence, so
That was a sentence. We might call that a paragraph, but I'll give you a pass on that one, Johannes. There's a growing community within robots in architecture and creative robotics in general. I see sort of the people interacting with me online thanks to my content rising over the last few years. And a big part of that is the Robots in Architecture Forum, where you're the most active user answering questions and sort of responding to people. What do you think are the most sort of the largest successes and failures of the forum and the discussions that are happening on there?
yeah. I mean, it's always difficult to see how the forum works. I think at the moment, the forum is very much a support forum. So if you look at the kind of questions, as you mentioned, I'm the most kind of active member. So basically, people ask questions, and I try to reply to them and help them as best as possible. So it's not more something as a way of providing support than something to really have the community come together. But I think this is kind of also inherent in the kind of community that we have, because it's kind of very diverse. So people come from hugely different backgrounds. You have people from the core field of robotics who know everything about KUKAs and ask about very kind of basic grasshopper questions, where you kind of think, well, is it really, that's not really KUKA prc, this is just you need to learn how to use grasshopper, to be honest. On the other hand, you have people who are total grasshopper experts who can't really turn their head around the limitations of a machine like a KUKA robot. And so I think this kind of is still a challenge for the community. But I think it serves as a good kind of knowledge base to get started. But I think then kind of the big step is then really videos that like you provide. So I think this is then kind of important for people to see it in action. And this is stuff we never managed to do. So if you talk about shortcomings, don't remind me of a KUKA prc manual. So this is really just something that always gets somehow reprioritized to the back of the queue, and then the software develops. You think like, well, by the time the manual is out, then it's already not current anymore. So this is a challenge that we just have with our particular kind of business model, which isn't really a business model. So I mean, this is, I think, very important that we do this basically in our spare time as a kind of project, not in a But yeah, it is actually, this is what it is. We're lucky to have this kind of overlap between what we do for earning money, like the work at university, and what we do as the association and with the software, because there is a good overlap. So it's definitely not wasted time, but it's kind of time on the side. And yeah.
Well, there's how many nights do we send a message to the other and it's what are you doing? And it's work, but it's not work, just robotic or exploring some idea that shouldn't be done in hours. So it's not the worst problem to have, but it's also still probably a problem, I would say.
Yeah, and it
But I'm
never
not
really
complaining.
stops. I mean, this is also nice. It's just a international group of people, so you can be sure at whatever time you check your emails, there's going to be a new question in there. But that's also part of the fun.
So from this community that's built up around KUKA prc and the association, you're responsible for RobArch. And as someone who studied architecture and has become a lead developer of a plugin and a robot programming platform, I guess I should say, how is it being responsible for an international conference like RobArch?
Well, I think what's important for people to know is that unfortunately, we don't do the hard work there. So, really, the hard work is done by our local partners. So, I mean, we did the first conference in 2012 completely by ourselves with basically no budget and quite a few constraints, but it was still a very, I think, memorable conference. Then 2014 was at the University of Michigan, 2016 University of Sydney, 2018 by ETH Zurich. And the local partners are really the ones that definitely put in the most hours into making that happen. So our job as the association, and our in this case applies to Sigrid and myself mostly, is to have this continuity, because it is a series of events and there are certain expectations to be met, there are certain kind of formats to be kept. So it's important that every local community is different. And I think it's super important that these kind of international conferences involve the local communities as much as possible. But at the same time, we need to look that kind of some formats stay the same because it is a series. And this is primarily our job to kind of keep the sponsors kind of continuous, that not every conference needs to start searching sponsors from scratch, but we have our reliable partners that we can then approach to realize that together. We have our partners at Springer to publish the book. So also here, quite a lot of knowledge is already there and we can support them to make it as fluent as possible. But all the hard work of, I don't know, it doesn't sound like hard work picking the snacks for a conference, but it is hard work. And doing all those calculations and assigning your students to assist with that. So this is all a big chunk of work. And here the credit really goes to our local partners.
Now, with everything that's happened this year, obviously the conference didn't happen. Is there any news on if and when it's going to return?
No, so we know that we want to organize it again as soon as possible. So I think this is clear. There are many people who are actively asking us all the time when it's happening, people offering to host it. So we're very happy to be in this kind of community that keeps together. And we're also, I think, kind of lucky that we were at a stage for the 2020 conference that was supposed to take place at Tsinghua University in Beijing, that all of the initial lockdowns happened at a stage where we were still able to cancel the event with relatively little expenses. So of course, many people put in a lot of hours. We went to China, discussed with our local partners. So there was a lot of effort that was hopefully not wasted, but invested. But at the same time, it was not like everything was booked and then we had to cancel, or we had to do a conference with half the countries not being able to attend. The kind of unfortunate situation, really, or not unfortunate, but the tricky situation with Robach is that we feel that the core of the conference really are the workshops. So the conference part is important and good, and the book is excellent to keep as a record. But I feel like the heart of Robach are really those interdisciplinary workshops with really high-end institutions, with universities, with companies. And there is no kind of really good enough way to do this online. So there are very good online formats around, but it's always kind of a compromise. And we feel like the heart of Robot is really getting people together in a room, and also to have this kind of undecorated, unobstructed view of how research and robotics works. Because in the papers and also in the videos, everything seems to work like magic. You push a button, you change the parameters, and the robot builds up your house more or less. And the truth is, of course, that no matter if you're talking about a tiny university or a huge institution, we all deal with the same problems. And I think this kind of reality check and to see how it is just a challenge. It's something that everyone needs to go through. And I think it really helps to experience that, to learn from each other. And we hope to do this soon. But to be honest, not counting with 21. So I think this will be something that we're skipping 20 and then starting again in 22.
One of the most common questions I receive online is one that I feel woefully unprepared or unqualified to answer, which is how do I do what you do, or how do I become a roboticist? Which I honestly don't have an answer. And I was wondering how you would answer that question.
That's a good question. I think the interesting thing about the kind of work that we do with industrial robots, that it's not really covered by any individual course. So just in a very anecdotal way, I can say that, for example, my younger brother studied mechanical engineering, and he really wasn't exposed to industrial robots at all in the bachelor, and then also afterwards in the master, only in a very lateral way. So you would kind of assume that, well, of course, it's the mechanical engineers who do all the robots. But actually, for them, industrial robots are kind of boring because these are already commercial machines. So then they're kind of developed, they're only iteratively improved. So they're looking for the kind of next mechanical thing in a way. And then if you think of computer science, well, it's kind of the same. So for them, some of them end up in robotics, but many other things. So there really isn't a way to, I think, efficiently study what we do. So I think really the nice way about architecture is that it prepares you to deal with complex data. It prepares you to deal with this kind of transition from digital plans or models to a physical model. So I think studying architecture is definitely not the way to become a roboticist, but it's not the worst thing to prepare you for it. Because many of the problems that we have with robots, we also have in architecture. And yeah, so I couldn't tell you what you should study. I think really the way is to start working with robots as much as possible, just to explore the possibilities. And of course, I know that this is easier said than done. So I personally am in a bubble where basically many people I know have robots at home. So I think just at our department, 2 people have their private robots at home, and I'm sure it won't be long until you get yours. So I'm not planning to get one. I got a kid, so this is the keeps me busy. But but I think this is stuff that is now happening, that these machines become more accessible through like fab labs and maker spaces. And I think this is a really important kind of development, that people don't need to buy a 10, 20, 70,000 euro machine, but instead they can become a member at an institution and then be exposed to that in a much more easy and affordable way. So I hope that there will be more kind of these kind of initiatives to push robots, make them more accessible, not only on the software level like we're doing, but also on a hardware level.
You've obviously been involved with robotics, and especially creative robotics and robotics within architecture. Over your career, what would be some of the standout projects you've been involved in?
Ooh, standard projects.
If you had to
Um,
pick top 3.
Top three. I think one of the core projects that was just super important for us as robots in architecture was a European Union funded FP7 project. It was called Arosu on stone chiseling with a robot. And this was, I think, for us just a super important thing to also, on the one hand, in a financial way, to get the funding to do this independent from university. So Robots in Architecture was a technology provider here and research partner with a consortium with TU Dortmund, with Labor and quite a few other companies. And the client was Bamberger Natursteinwerke, a stonemason company in Germany. And the idea was to get a robot to chisel stone surfaces. And that was super interesting and I think also very formative for creative robotics in a way that I understood how important it is to really kind of understand the process if you want to automate it. So we really were only able to develop the kind of hardware that was done mostly by TU Dortmund, but also the software from our side after we were at Bamberger and we did those high-speed camera and force torque measurements. So that was really kind of the point where we all of a sudden understood how this is working and why this hasn't worked before with other means. So we, of course, had our hypothesis, but only then we were able to say this is how it is. I think this was super important because you can program all you want. If you don't understand the process, it doesn't lead you anywhere. So I would put this actually at probably at number one. Number two, just because I very, very much liked the project, was last year's Ars Electronica underbody project, where you were also involved with our 5.
Not really.
Yes.
It was memorable. I'll say that much.
Where we had our 5 collaborating robots basically programmed through motion capture, working in perfectly simultaneity, whatever, with a dancer. So that was just a very good experience working with so many robots. This is what I like about these Ars Electronica projects. There's never really much money involved, but we were able to kind of sell KUKA on the idea that having 5 robots on stage would be cool, and they supported that. And then we were able to set it up in a very short amount of time. Because I think with research projects, sometimes this is a kind of a challenge that after 2 years, whatever, you kind of get bored of the topic. And with these kind of short-term projects, you just have 1 month or a couple of weeks to set it up, and then you have it on stage, and then you can think of the next thing. So I think that's enjoyable.
You say enjoyable? I had just landed in Austria to join the team, and I would say that's trial by fire on my side of, oh, hey, here's 5 robots interconnected with software that I've developed. Can you look after them for the afternoon? Yeah. Sink or swim. It was definitely memorable.
I remember us having I think 2 smart pads per person, being very nervous if the simulation will fit the movement or if it will kind of crash into the floor, and
all hands on emergency stop.
That's very ready to stop them, and but still they were moving just in such a fast way because it wasn't fast movements of the dancer, but just achieving this kind of speed with a much smaller robot. Yeah, that was exciting. And also during the show, that was also exciting. And that was fun.
Fun's a word for it, absolutely.
Nothing broke. Let's put it like this. No people were harmed, no robots were harmed, so we're very lucky to manage that properly.
And number 3?
Number 3, no, that's hard. 1, 2, 3. I don't know. I wouldn't say that I was involved, but it's a project that I show quite a few times because it nicely showcases what the software is about. And that is the Stuttgart 21 train station, where the concrete formwork was built by Züblin. So they're a timber company. And Thomas Wieland is the robot guy there who did the programming with some, I think, also external consultants. So no credit from our side. We just provided the software. But I really like showing it because they have such a nice kind of history. So they're a timber company. They invested in robotics very early on, before there was anything like CamRob that I mentioned at TU Vienna. So it was long before that. And they just bought a machine because they figured that sounds interesting. They set it up and then they had to program it, but there was no software to program it. So they started programming it through an environment that they knew, and that was Microsoft Excel. So really your calculation sheet, whatever. So they were plotting toolpaths with the normal plotting function of Excel just to have some kind of simulation. And they were very successful. So quite a few high-end buildings were built through that interface. So there's no, I'm not belittling this at all. So this was super impressive that they managed to do that. The problem for them was that this was not kind of a very maintainable solution. So that was a project that grew and grew until it was not really manageable that easily anymore. So then they looked for new solutions. And for them, the kind of idea was that they don't want to go for CAM software, in a way that CAM software is often optimized for metal production, because this is where most of computer-aided manufacturing is coming from, and also available to all their competitors. But they said that they want to kind of implement their own material knowledge into this environment. And then they choose KUKA prc as the interface. So again, we didn't contribute anything on the programming side. That was entirely their thing. But I think as a project, it kind of shows you with kind of driven and enthusiastic people how you can really make this happen, and then how to continue evolving kind of this idea of robotic fabrication.
So having looked backwards at the last decade, for the looking forward, obviously what we're working on in-house, we're starting to do a lot more real time, no longer just exporting the code, but more running it and developing the loops like you mentioned earlier, where we're really experimenting what we can do with these machines. Where do you think, the next 5-10 years we'll see a roboticist going?
Tough question. For me, I mean, you mentioned the technical stuff already, with real time, with cloud, and all these kind of aspects. For me, something that will be a core development within the next years is really this idea of collaborative robotics, and not in a way of kind of very sensible robots, but how to in a more legal way. So how can we find ways to interact with robots in a safe, but at the same time in a legal way? Because for many of our projects, we are working in research and development. So we are not kind of, the machine directive and these kind of guidelines don't really apply to us. So we have this situation that we don't need to worry that much about safety, or we worry about it on a very practical level. So we try to reduce the risk to ourselves, to our colleagues, to the robot, but we don't need a CE certification for everything we do. But at the same time, I feel like this safety is really one of the main aspects that is, on the one hand, very reasonable, but also holding back innovation. And now the developments that we're seeing with collaborative robots, but also expanding to autonomous cars, for example, they bring up kind of very interesting new aspects in regards to responsibility, safety, also ethics in a way. And I really hope that this will lead in kind of new ways how we can approach robots in a safe way, how we can install it in a commercial context without this kind of shadow of illegal installation hanging over us. And I think this will be very interesting to see how those safety guidelines evolve with more collaborative robots, and this kind of also industry drive that industry wants to have collaborative robotics, but it's still kind of not as easy as it should be, maybe.
Well, I think you know my opinion on the cobots versus the robots, where you give up so many of the characteristics of an industrial robot to make it collaborative, and then it's becoming almost moot. There are very good use cases that have been seen, especially over the last year, where they have something autonomous running for 24 hours a day. But you do lose the characteristics which are what made me fall in love with robotics in the first place. A giant Quantech or Fortech that can move around 100 kilograms at 2 meters a second, or do something very patient without someone being there to monitor it. So it's definitely a way to move forward. How do we get the characteristics of an industrial bot closer to a cobot in the way that humans are able to interact with them? And who knows, maybe someone from Creative Robotics will have something on that topic in the next 1 to 3 years.
I would expect that. No, so I think really cobots and robots, these are kind of at the moment kind of different machines. But at the same time, it's kind of also, I don't think it's a good situation that they are so far kind of apart. So like in KUKA, where you have the KRC 4 and 5 controllers on the one side and you have Sunrise on the other side that works in a very different way. And I think this will be really important in the future going forward to put this into kind of one shared environment where the robots have different capabilities, but kind of the core programming is the same. Because the Java stuff is, it has its big challenges, but at the same time, it can do some things pretty well. And I think this is really something like proper object-oriented programming is something that's really missing. So I hope that we will have this kind of jump going from cobots to industrial robots and to have more kind of cross-pollination in a way going on between these different kind of streams of development.
Yep. Okay, so the last couple of questions. I'll give you the opportunity, if there was one top tip for KUKA PRC that you could say to, I imagine the majority of people who come to my YouTube channel are interested in Grasshopper and more particular KUKA PRC and robotics. What would be your number one top tip for someone just beginning KUKA PRC?
Someone just beginning KUKA prc, what would I tell that person? Look a little bit into tools and bases.
I was hoping you'd say something different because that would be mine as well.
Yeah.
It's only the tool number that goes across.
Yeah, and it needs to fit, otherwise you don't get a reliable simulation. So we had, this is really the one thing that is kind of, in a way, dangerous. If you have your kind of wrong number, you expect it to just move in a place and then it moves differently and then you have a problem. So having this kind of typical terms, so sometimes we, and definitely we get those questions when people have super basic kind of question. You see that they don't really understand what they're doing, or they just, for example, they live in a very constrained robot system. So I don't want to say any names, but we had some discussions with the university and they did some very nice milling stuff with their robots and some super interesting projects. So they know what they're doing, but at the same time, they worked within this very enclosed environment provided by the integrator. So they had kind of placeholders for the turntable, they had the global coordinate system, they had some way of picking tools off the tool changer, but no really this kind of understanding of how all this works together. And so it's interesting to see how people get there. But I think this is also maybe helpful with KUKA prc and this software. You're then exposed to the more kind of underlying concepts, and you need to worry a little bit about them.
I think it might have been at least 2 or 3 emails back and forth from Tasmania to Austria when I finally understood what you meant by these numbers are not going over, check your tool data. And I was like, yeah, the simulation is fine. Why is the robot doing something else? The robot should just do what it's told. It's a machine, like a printer, right? Not quite. And finally, Johannes, thank you very much for your time. I think the last question will be, what's the future for KUKA PRC? Are we going to see PRC 2?
I think we are technically at KUKA prc 3, but we stopped numbering at some point. So I think the first one, if you look at it from the colors, the first one had gray robots. The second one had yellow robots with gray tools and black bases. And now we have colored robots. So that was kind of for us the kind of big steps, because it sounds trivial to change the color of the robot, but it always had very big underlying architectural changes to make this and other things possible. But yeah, I mean, for me, what I'm really interested in is at the moment how Grasshopper is going to evolve. I still very much enjoy the platform, the kind of many plugins, the way we work with it. As I said, it's limiting in some regards, but I think many of those things McNeil and David are aware of. So at the time we're recording this, Rhino 7 has just been released. So they're now starting with Rhino 8. So hopefully Rhino 8 will finally be the Rhino with a new Grasshopper. Because at a basic level, we're still having more or less the same Grasshopper that we've been using since we started developing KUKA prc. So in those 10 years, there hasn't been huge changes to it. So I think this will be really important in the kind of further discourse, how the development is going to continue. And beyond that, yeah, we just try to be flexible to and as always it will evolve with our projects. I mean, this is the nice part, that there is no abstract customer where we say we want to do this, but basically depending on what projects also we at Creative Robotics will do in the future, that will then also shape in which direction we're going to continue developing it together, which is the nice part.
Oh, wonderful. Well, thank you very much for your time this evening, Johannes. I look forward to sharing a beer with you once this lockdown is over.
I'm also looking forward to that. So that was fun. We've been postponing that for a very long time now. And yeah, we finally made it. So that's great.
And it's been lovely catching up.
Excellent. Carl, then see you soon and have a perfect evening.
Ciao.
Bye.